again, boys and girls.
Hello again, boys and girls.
And cougar parents.
And cougar parents.
Can I hear a cougar roar?
No.
Oh, okay. Well, not today. Today we're going to take a look at volume. Volume. Can you say pump up the volume?
Pump up the volume.
Yeah. When we look at the volume of a three-dimensional figure, what we're really doing is we're seeing we're stacking the bases, and we'll talk a little bit of what that means. Volume also deals with three dimensions, whereas when we're dealing with area and surface area, that was just two dimensions. We're looking at the base and the height, also known as the width and length. Now we're going to add the third dimension. It's that dimension that causes it to pop out at us. Are you okay there? Feeling a little sicky? Okay. Well, let's say bye to everyone as we take a look at volume. Say bye-bye.
Bye-bye.
Hello, boys and girls. Today we're going to look at volume. And as I said in the intro, volume is really stacking up the area. But before I unpack that statement, let's just take care of some basics first. Volume, first of all, deals with three dimensions. Okay? Area is only two dimensions. We have the base and the height of something, or we have the length and the width, whatever you want to call it. Okay, we only have two dimensions that we're dealing with, and that covers the area. Okay, how many squares will fit on a flat space inside a specific perimeter. But when we deal with volume, we have three dimensions. Okay, we first of all have the width, or I should say the length. Okay, and sometimes all these labels we call things can get a little confusing. Then we have the width over here, and then finally we all agree on this. This is the height. It's how tall our geometric figure is, or our solid is. Okay, and the way we find volume is we take these three dimensions, for a rectangular prism that is, and we simply multiply them all together. We take the length times the width times the height. We take these three dimensions, we multiply them together, and we will get the volume, the amount of space or cubes that will fit inside of this 3D figure. Our length is 3, our width is 4, and our height is 5. And by the way, those are all inches too. Can't forget my labeling. Setting a bad example. Sorry, cougars. Okay, let's fix this. Okay, so therefore the volume, we would take 3 times 4 times 5, and 3 times 4 is 12, and then 12 times 5 would be, well, 5 times 10 is 50, and then 5 times 2 is 10, so we would have 60. And we can't just leave it like that. We also have inch times inch, which would be inches cubed. Okay, so our volume is 60 cubic inches, or inches cubed. And I like to say 60 cubic inches because that means that if you had a little cube that was 1 inch by 1 inch by 1 inch, okay, you would have 1 cubic inch. There you go. 1 cubic inch, and we could take 60 of these little cubes and fit them inside of this three-dimensional figure. Now you're probably wondering, where does stacking up the area deal with? Well, see, when we have area, that's just two dimensions. Okay, that's taking a look at how many squares, not cubes, how many squares would fit inside of this rectangle. We have a rectangular prism here. And what a rectangular prism really is doing is it's taking a bunch of rectangles and it's stacking them. It gives us height. It gives us that depth. It pops out. It's no longer flat anymore. So if we take a look at our base face, which is a rectangle, right up here, what are the dimensions of it? It's 3 by 4. So this would have the area of 12 inches squared, right? Okay. But we don't have just one of these. We have 1, we have 2, we have 3, we have 4 and 5. Sorry about that, I got a little crazy there. So what we're doing is we're taking this, the area of our base polygon, our base face, which is 12 inches squared, and we're going to call that's our base polygon. Okay, so we're going to give it a big B. Big B stands for the area. Big B stands for, well, first of all, we find it by taking the base times the height of our base polygon. Okay, it's the area, okay, of our base polygon and we're going to stack it. See how many, the height, okay? Oh, okay. So the big B is basically our length times width, or our base times height if we're just dealing with area, okay? And the significance of that is why are we focusing on the area of this base polygon? Well, when we take 12 inches squared and we multiply it by the height, which is 5 inches, what happens here is 12 times 5 we know is going to be 60, and inches squared times inch is going to become inches cubed. Okay, so our volume, and you're going to see this formula in more advanced mathematics. You're going to drop the volume, and by the way, volume is equal to length times width times height will only work for rectangular prisms. Let's take a look at something a little different. Let's take a look at a triangular prism. Okay, we're not going to get rid of all that. Okay, let's see how quickly I can draw one here. Let me get my pen back. I got it back. Okay, so here is our triangle. Okay, a triangular prism. Okay, our triangular prism. And we're going to say that it has the height of 3. It has the base of, let's say 6, and it has the height of 8. Okay, so we say that volume is equal to the base, big B, times the height. Now this big B, once again, stands for the area of our base polygon. This is a triangular prism. Okay, what's a triangular prism? You take triangles and you stack them on top of each other. You see how high? So if this triangle, what's big B going to equal? Well, big B is equal to the base times the height divided by 2, because now we're dealing with a triangle. See, when it was a rectangle, it was just base times height. That would have given us the area of our base polygon. But since this is a triangle, it's base times height divided by 2. And our base is 6. Our height is 3. And we want to divide that by 2. And 6 times 3 is 18. And 18 divided by 2 is 9. Okay? And that would be 9 inches squared. Okay? With this, or units squared, whatever it would be. Okay? Okay, so we've got our big B, therefore, is going to be 9 inches squared. Okay, and what's our height here? Our height is 8 inches. So if you take a triangle that has a base of 9 inches squared and multiply it. You stack it on top. I don't know if I can draw 8 of them. Let's see here. I'm just going to start chopping it in half. I think I'm going to get in trouble. Yeah, I'm going to get in trouble, but let's give it a try. Okay. Right there we got 4, and then if I do this, it's starting to look like a multi-layer cheesecake or something. Okay, we've got 8 of these triangles stacked on top of it. The area of 8 of these triangles. Well, I'm sure you've already done the math. It's going to be 72 inches cubed, or 72 cubic inches, and that's our volume. And there we have it. So actually, as far as 7th grade, I should say 6th grade mathematics are concerned, you're not going to really get into finding the volume of triangular prisms, but you will be responsible on the EOGs for knowing the volume of rectangular prisms. And you can remember it 2 ways. Volume is length times width times height. We have 3 dimensions. You multiply those 3 dimensions together and you will get the volume. And volume, once again, means how many cubes fit inside the space of our solid or 3-dimensional figure. Or we can say that volume is equal to big B times H. Okay, and big B is the area of our base polygon, and then we multiply it by its height, because it's how many of those areas are stacked up on top of each other. Either way, that gives us 3 dimensions. So that's it for volume. I hope you enjoy this lesson, and let's practice some. Bye-bye.